Welcome student to the next lecture of halogen derivative. Today we'll continue with the reaction of alkyl halide, and today first we'll be doing dehydrohalogenation reaction. Dehydrohalogenation reaction. Actually, it's an elimination reaction. What we are studying elimination reaction, and in this elimination reaction we'll be studying dehydrohalogenation reaction. It is also called as alpha beta elimination reaction. Okay. Now, what is this elimination reaction? Let's understand. Actually, elimination reaction is that reaction in which two atoms or two group of atom is removed and it results in the formation of alkene. Okay. Let's understand with a general example. Carbon and carbon, right? Suppose halogen is attached to this carbon. If halogen is attached to this carbon, it will be called as alpha carbon, right? And obviously hydrogen will be attached to all this carbon, so this will be beta carbon. Okay, now what happens when I treat this with KOH? But very important student, this KOH must be alcoholic. Okay, because when we take aqueous KOH, substitution reaction take place, remember that. But when we take KOH which is alcoholic, then in that case reaction is not substitution but elimination. Why it is like that we'll understand, but for time being you just see the reaction. Okay, so I take some alkyl halide. This is nothing but alkyl halide. I take some alkyl halide. This alkyl halide is treated with alcoholic KOH. I hate this, right? Now what will happen? The product will be how the product will form. Let's understand. Suppose the bonds from here breaks down, okay, and the bond also breaks from here. So if a bonds break here, right, this bond, this carbon and this carbon form double bond over here. So if it form double bond, it result in the formation of carbon-carbon double bond, right? It will be like this, and it result in the formation of alkene. Okay. And what will be left? This will remain as what? H plus, and this will be X minus. How this happen? What will the final product? We'll see in the example. But this is what happens, right? What we have to understand at this point of time, that there's something which get removed from one molecule. Because it is removed, okay, nothing is added. It is called elimination reaction. An elimination reaction is taken from alpha and beta position. That's why it is called as alpha beta elimination reaction. Okay, and next that it form alkene. That is what you have to remember. With that, okay, let's see. We'll see some example. First example, suppose I take ethyl bromide. And I treat this ethyl bromide with what? KOH. Again, you should understand this is alcoholic. I hate this, right? What will happen? Okay, Understand, student, it will not result in the formation of HBr. Many times students do mistake in that. They result in the formation of H. No, HBr is not formed. What is formed? Actually, this OH combined with this H, so it results in the formation of H2O. This K combines with Br, so it results in the formation of KBr. Okay, and since they goes out here, there will be formation of double bond, so it results in the formation of H2C double bond CH2, that is nothing but alkene, that is ethene. Okay, and this is 1 degree alkyl halide. What will happen if I take 2 degree alkyl halide? Let's understand. Suppose I take CH3 CH3 and I take here Br. Okay, this is 2 degree ethyl isopropyl bromide, right? Again, treat this with KOH. I hate this. What will happen? See, CH3. Can I write this CH3 as CH2? And I write here what? H. It's one and the same thing. Okay, this OH will combine with H to form water, and this K will combine to Br to form KBr. So I will have H2O, I will have KBr, and here there will be formation of double bond, right? Okay, product will be CH3 CH double bond CH2. I hope this is clear. Okay, I take one more example. I take 3 degree this time. CH3 CH3. I take here suppose Br, and here I write like this CH2 and H. Now student, understand this. This is Br is attached to this carbon, so this carbon is alpha carbon. This one is beta, even this one is beta carbon, even this one is beta carbon. So H can be removed from beta position either from this, this or this. But I have taken from simplicity, I have taken from here. So Br will get off from here, H will be get removed from here. Okay, they are going to react with what? KOH, alcoholic. So it reacts with KOH, which is alcoholic. Tell me the product. Product will be CH3. This will become CH3 double bond CH2 plus what? Plus H2O plus again KBr. What is the name of this? Let's see what is the IUPAC name of this. I number it 1, 2, 3. Okay. Second position there's methyl. So what will be the name? The name will be 2-methyl propene. Alright, that's simple. Okay, now we'll understand the mechanism of that, and we'll also understand why HBr is not formed. We'll also understand why there's a formation of water and KBr. We'll understand each and everything. We'll understand the mechanism. So let's see. Mechanism of this reaction. And we take a simplest example. That is carbon, H, Br, H. Now when I take alcoholic KOH, this alcoholic KOH will become obviously K plus and OH minus, right? And this will take place in alcohol. When I hit this, reaction will start. And understand, very important thing. When we have seen aqueous KOH, in that case, this OH minus act as a nucleophile, right? But when this OH minus will produce in alcohol, this OH minus will not act as a nucleophile, but instead it will act as a base. Understand this, student? It's very important. Here, this OH minus will act as a base. So what did the base do? Base abstract the hydrogen and it result in the formation of water. So let's see what happened. This OH minus will go here, and this, when it goes, it will abstract this hydrogen. How? This OH will give its electron to this, right? So when this hydrogen will accept the electron, so the hydrogen will give the electron to this carbon, right? When hydrogen will take the electron, okay, then this hydrogen, understand, suppose OH minus comes here, there's a 2 electron, one is of hydrogen, one is of carbon, right? So when OH comes and gives its electron, hydrogen gives electron to carbon, and OH combines with H to form what? To form H2O. So water is formed. Now understand how many electrons is left with this carbon? 1. This is of its own electron, but this electron is of hydrogen. As a result, this carbon will acquire negative charge because it has got 1 electron from outside. So, but we understand that carbon is not electronegative. Since carbon is not electronegative, it does not have any tendency to retain that electron. He wants to get rid of that electron. So what he's going to do, this electron of carbon will go to this carbon. I mean, this is going to give this electron to this. But when this carbon will get that electron, obviously, see here there's a negative charge, but once this electron is gone, it will not remain negative, it will become neutral. But now this carbon will get negative charge, understand this, right? But again, the same story, carbon can't remain negative as it is not electronegative, but this carbon have opportunity to get rid of that electron. What is that opportunity? How it can get rid of the electron? This carbon will give his electron to Br, right? So Br will come out as what? As Br minus. Understands? This comes up because he was getting negative, the electron, he has given his own electron, so this will become neutral. That means 1 electron will left, and this electron will form double bond. As a result, we form alkene, that is H2C double bond CH2. I hope you understand. This K and this Br minus will result in the formation of what? KBr. So that's how KBr is formed, that's how water is formed, and that's how there's a formation of alkene. Understood, student? Okay, now we'll see some more examples. Okay, but understand the mechanism, right? Now let's see one example. CH3 CH CH2 CH3. Okay, now treat this again with KOH, alcoholic. Okay, just think of the product, student. Here, let's understand, we have alpha carbon, this one is beta hydrogen, this one is beta hydrogen. That means now hydrogen can be taken out from 2 carbon, can be, I mean there's a possibility. So hydrogen can be removed from here and hydrogen can be removed from here, right? In other case, in the last one which we have seen, there also we can remove, but the answer which we have got at that time would be same. But here the answer is not going to be same. How? Let's see. Suppose the hydrogen moves from here, the product will be what? CH3 CH double bond CH CH3. Understand, student? The H from here, Br from here will go on and here to form double bond. But if I remove the hydrogen from here, the product will be what? The product will be CH2 double bond CH CH2 CH3, right? This is but 2 in, and here this is but 1 in. Both the alkene are different, okay? And in this, one is present in major amount, one is present the minor amount. That means it has given me two products, and this product obtained will be 80% and this will be 20%. That means this is going to be major one and this is going to be minor one. Now the question is how to identify this, how to identify that, which is going to be major product, which is going to be minor product. Okay, so if you remember, we have studied something called as Markovnikov rule. In the same way, there's one more rule that is called as Sedzev's rule. What this Sedzev rule says? Okay, it says that when there's a possibility of giving hydrogen from two or more than that, then the hydrogen goes from that carbon which contain less number of hydrogen. Okay, that means here also we can see hydrogen can, if moves out from here, okay, hydrogen can also move out from here, right? But hydrogen will remove from that where it contain less number of hydrogen. That's what the Sedzev rule says. Understood? And how to identify which product is going to be major product? Okay, that's the one question. How to identify which product is going to be major product and why it is like that? Okay, student in 11th standard in GOC, that is General Organic Chemistry, you might have studied something called as stability. Okay, stability is decided on the basis of resonance, hyperconjugation, inductive effect. Okay, here we have to look for hyperconjugation, right? And hyperconjugation depends upon the number of alpha hydrogen present in the product. If you see here, right, understand, this is unsaturated carbon, right? How many beta hydrogen is present in this? Understand, student, how many beta hydrogen is present? This is to carbon unsaturated. This one next to this, how many hydrogen? 3. Here how many? 3. So total number of hydrogen is 6. So there will be 6 hyperconjugating structures. But here if I look here, carbon-carbon double bond, here I have only 2. Understand how many alpha hydrogen I have? Okay, I have only 2. Got that? Okay, so that's the reason it will have major hyperconjugation product, and that's why it's a major product. I hope this is clear. Okay, so henceforth, whenever you solve a question, you have to understand that the major product will be that product which will have more hyperconjugation, and that more hyperconjugation can be decided by what? You have to find more number of beta hydrogen which is present. Got that? Sure. Okay, now moving further, we will study one more reaction, and then we'll be completing today's lecture, since we'll be completing our chemical properties. Okay, now next reaction, this was very important one. Next reaction is again a very important one, that is Grignard reagent. What is this reaction called? Reaction that is formation of Grignard reagent, and this is simple one. Formation of Grignard reagent, and that's simple. Okay, we take student alkyl halide Rx. Obviously this is a reaction of alkyl halide, so we take Rx, alkyl halide, and we treat this with magnesium. We treat this magnesium in the presence of dry ether. In the presence of dry ether. Okay, what is dry ether, student? Actually, ether is a liquid. So why we call it dry ether? Because when ether is formed, there's also some formation of water molecule. Okay, so for example, you take some water and you put few drop of oil in that, so that oil will float on that. Okay, so I will are you getting, or in the other way, understand in a different way. Suppose I take few oil, right? Okay, I take some oil, and in that oil I put few drop of water. So I will not call as a dry oil, right? Because why? Because water molecule is present, or some water droplets are present. Now assume I take some chalk, right? That droplet which is present, I remove that water droplet by using that chalk. Okay, so now chalk is going to soak all the water, so now your oil will become free from water. So I can call that oil as a dry oil, although it is in liquid state. I hope you're getting that. Same way, when I have ether also contains some molecule of water. We remove that water, and now that oil, although in a liquid state, is called dry ether. Okay, and why we do that? We do that because if water is present, then reaction will take place with water and not that with this magnesium, and that's the reason we remove that water. Okay, now, so this what is going to happen? This magnesium will come between this, and it results in the formation of RMgX, alkyl magnesium. This is called alkyl magnesium halide. What is it called? Alkyl magnesium halide. We'll take some example. Suppose I take CH3 Br. I treat this with magnesium in the presence of dry ether. It results in the formation of CH3 MgBr. Okay, I take C2H5I. Magnesium condition remains same, C2H5 MgI, ethyl magnesium iodide. Okay, this is how the reaction take place. Now understand, student, one thing very important. Okay, now this RMgX, this magnesium, we all know magnesium is what? Electropositive in nature. So if it is a magnesium, this is acquire partial positive charge. But how you can acquire partial positive charge? By giving electron, because magnesium is a metal, and metal have tendency to give the electron. So this try to give the electron to this. So this acquires partial negative charge, and this also acquires partial negative charge. Right? And why this? I said this is very important because Grignard reagent is a very important reagent. It almost react with every substrate we have. Almost react with every substrate we have. And in every chapter, okay, you will find how the reaction of Grignard reagent take place with other reagent, with other substrate. So that's the reason it's very important. Okay, student. Now, see, we have completed actually the chemical reaction of alkyl halide. Okay. In next lecture, we'll be studying very important part, that is SN1 and SN2. That's very important, student. That's very important, SN1 and SN2. But before that, we have to understand that is actually a mechanism of nucleophilic substitution, right? But before that, we have to understand about some theoretical part, where we will be studying what is ordinary light, what is monochromatic light, what is plane polarized light, what is optical activity, what is a racemic mixture, what is dextrorotatory, what is levorotatory. There are lots many things which you have to understand theoretically. Okay, once we understand, then we'll study nucleophilic substitution reaction, and that is two type, SN1 and SN2. Okay, but that will be doing in next lecture, because we don't have that much of time to start with that new topic, so I'm not starting today. Okay, So for today we stop. Thanks for watching.